See here, in the wavefront of a plane wave, there are two medium. That means light is traveling from rarer medium to denser medium. This is the interface. This is the rarer and this is denser medium. These are the two rays, 1 and 2. These are the two incident rays. So this is when this touches, the first ray touches the interface at point A. It touches a point A. So the second one is still in the air at point D. Okay, the second one, sorry, point B. It is at a point B in the air. But now wavefront means a line perpendicular to the rays. Similarly, when this touches, when the second one touches the interface, already the first one might have already traveled a certain distance in the second medium, let it be a D. But the distance traveled by the ray, first ray, in the second medium is less than the distance traveled by the ray in the air in the first medium.
Yeah.
Okay, second ray in the first medium.
Yeah.
So now we are drawing the wavefront again. We already know that V2 is less than V1 and V2 tau is greater than V2 tau. So I will write the distances now. VC is equal to what? V1 tau and AE is equal to how much? V2 into tau. Now we'll draw a triangle. Triangle OBC and triangle AEC. Okay. So we write sin theta is equal to opposite side by hypotenuse. Okay. Sin theta is equal to opposite side by hypotenuse. Okay. What is a triangle now? He told OBC, ABC and AEC. Sorry, this let it be AEC. So ABC, in that ABC, what is that? BC by, we'll take the first triangle, ABC, sorry. ABC and AEC. Opposite side by adjacent side. So sin theta, sin I is equal to what? Where is I? This is I. If this is I, this will be I. How come? How come that is I? If this is I, he says this is I. How come? This is not reflection, this is refraction, right?
Yeah.
This is refraction. So what happened there? This is the angle, this is not the reflection, right?
Yeah.
This is 90 degrees, yeah?
Yeah.
Ray and this one will become 90.
90.
Then?
Oh, so I will be.
Well, the angle right next to it.
You understood now?
Okay,
What will be this angle? Okay, you tell me.
this one.
This is 90 minus
90, very good. Excellent. 90 minus 1. Okay?
that angle is also 90 minus 1.
Very good. Yeah.
So that will be it.
So this will be it. Understood now? Okay. So sin theta is equal to opposite side by sin I is equal to what? Opposite by adjacent side. So during 90 degree, this is 90 degree. So opposite side is what? V1 tau divided by adjacent side. Adjacent side is what? AC. Okay. Adjacent side is AC. Clear? Now after that we have sin R. Sin R is what? Sin R is equal to sin R is equal to AE by AC. Okay. Sin R is equal to AE by AC. Now what will happen here? It is equal to V2 tau. V2 tau by AC. Okay. V2 tau by AC. So sin I by sin R. Divide one over the other. So sin I by sin R. Sin I is equal to how much now?
There is angle now.
Now you tell me.
It's over there.
Okay.
Is it
Now
AC?
this is R. Okay, this is
Yeah.
R.
Then this.
Is
There is
it
angle.
EAC?
CAE is 90.
ACE.
ACE.
Can you take like that?
ACE will be R, right?
Yeah. Okay, let us draw. Okay, now this is R. Where is 90 degrees? This cannot be 90. Yeah?
Yeah.
This is 90, right?
Yeah.
Perpendicular.
Yeah.
90. Okay. So what is this remaining angle?
This 90 minus.
Understood now? So sin r is equal to V1 tau divided by AC, V2 tau divided by AC. This and this will get cancelled. Sin I by sin r equal to what? V1 tau by V2 tau. Tau will get cancelled. So what did we get? We got here
V2 sin I is equal to V1 sin R.
we got N1 is equal to C by V1. So what we got? Sin I by sin r is equal to V1 by V2.
Yeah.
Sin I by sin r is equal to V1 upon V2. We got this. And also we know that N1 is equal to C by V1 and N2 is equal to C by V2, right? Refractive index formula. C by V1 and C by V2. Now we also have one more formula. What is that? N1 sin I is equal to N1 sin I is equal to N2 sin R. Okay, N2 sin R. So you can write like that. N1 by N2 is equal to sin I by sin I by sin R. So N2 by N1 is equal to sin I by sin R, right? Yeah. N2 by N1 is equal to sin I by sin R, which is equal to sin I by sin R, which is equal to V1 by V2, right? Yeah, it will become equal to V1 by V2. Sin R by sin A, how it is? Yeah, that is that problem. N2 by N1. Yeah. So now lambda is what? Okay, you don't write this step. Leave it. This you don't write. Okay.
Because
This is not. No, don't get confused with that. Okay. So here we have lambda one is the wavelength in medium one. Lambda one is wavelength in medium one, and lambda two is wavelength in medium two. Okay. Lambda one is wavelength in medium one. Lambda 2 is the wavelength in medium 2. So what is lambda 1? Lambda 1 is BC. Lambda 1 by lambda 2, right here. Lambda 1 by lambda 2 equal to what? BC by AE, which is equal to what? V1 by V2. Lambda 1 is the wavelength.
Yeah.
Suppose now what he said is, instead of writing like this, he said like this. Got it now?
if we represent it as waves.
One wave. This wavelength will be shorter than this one, right?
Yeah.
This wavelength is both and this wavelength is dash. So he write BC by AE is what? V1 tau by V2 tau. Tau got cancelled. So that is actually wavelength, right?
Yeah.
Okay. So that is how we got that. So therefore, what do we get now?
Sin I by
So
sin R.
V1 by lambda 1 is equal to V2 by lambda 2. Okay. So what is happening here? So that means what? Nu is equal to V by lambda remains constant. Means what is the meaning? When the light is traveling from one medium to another medium, does the color of the light change? The light is traveling from air to glass. Does the color of the light change? Only the wavelength changes. Why? Because of the velocity of the light. Understood now? Keep this in the mind. This is very, very important. He brought this, he explained this from there. Understood? That means what? When the light is traveling from one medium to another medium, wavelength changes. Wavelength is changing because of what? Velocity, not because of the frequency. Frequency remains constant. Frequency remains constant. Understood now? Is it clear? So this completes your first derivation. Understood? Is it clear? Did you understand, Mr. John? Now, I'll go with clear. One. We'll go with the next one. That is refraction at a rarer medium. Okay. Refraction at a rarer medium. Okay. Clear, Mr. Sayyid?
Yes.
Now, refraction at a rarer medium. So now, what is happening now? Light is traveling from denser to rarer medium. Okay, light is traveling from denser to rarer medium. So we are taking two rays again. Okay, so it bends away from the normal.
Yeah.
Yeah, it bends away from the normal. So what we have taken? These two are the incident rays. So this is the wavefront, right? So here, now this is the normal. Now we can draw it faster when compared to the previous one. This is I, and this is what? This is incident wavefront. Okay, this is incident wavefront. Incident wavefront. Okay, and this is A B. This is what? V1 tau. Okay, V1 tau.
Yeah.
Now what happens? The thing is, it is traveling like this. Okay, so what will happen? Sorry, it bends away from the normal, right? It bends away from the normal. So I am drawing this is here. So this is
Same thing we do.
yeah, but we are not going to waste our time. But already we know that V1 is greater than, so therefore N1 sin A is equal to. But already we know N1 sin A is equal to N2 sin A. Okay. We get the concept of critical angle from here.
Oh, okay.
Okay. So N1 sin C is equal to N2 sin R sin 90. Can I write like this?
So how can we write sin I as sin C?
If the angle of incidence is greater than critical angle, so equal to critical, then what the particular angle what happen? The reflected ray grazes along the surface of 2 medium. Okay.
So this is perfect.
So what will happen here? This will become n, this will become 1. Relation between refractive index and critical angle. Okay. If I is greater than C, what will happen? So then that is total internal reflection. Total internal reflection. Yeah.
So in exam they can ask prove the formula for total internal reflection
Using Huygens principle. You will be drawing the old one and you will not get the marks, and then after all you will talk to the examiner and me also. Yeah. Yeah. So shall I go ahead then? Okay. Now, reflection. Now reflection we'll discuss. Okay. We'll discuss the reflection. Then I will stop for today. Okay. Interference we can see tomorrow. Okay. What time is your Chem class tomorrow? Maybe. Okay. When you once you get the information, just tell me. Okay. We'll fix it. If he is not giving, then make it 10 tomorrow. Okay. Now. This is clear, right? Perfect. Yes, Joan. Is it clear? Now, reflection at a plane. Reflection. Reflection of a plane wave. Reflection of a plane wave by a plane surface. Now, here. Now there are two wavefronts, like two rays. Okay. Okay. There are two parallel rays. Okay. Now, this is the normal. This is the normal. Okay. Both are incident. And what is this? This is the wavefront, right?
Yeah.
These are the rays, and this is the incident wavefront. Incident wavefront. Now what happens? We already know that incident and angle. This is I. Reflect back into the same media, right?
Yeah.
Yeah. So this also will reflect back into the
Same.
same medium with the same angle. Okay. This and this will reflect. Now what happens? This will become the yeah. Is it the same? Something like this. So what will happen now? Yeah. By the time, yeah. Reflect incident wavefront. Yeah, it was in the air. When this is touching, this is already in the air, right? See, when this was touching the interface mirror, this was in the air, right?
Yeah.
Similarly, when this was in the air, this is touching the
That is
interface.
touching the interface.
Is that clear now?
Oh.
So this is incident and this is refracted wavefront. Okay. So reflected wavefront. Reflected wavefront. Reflected wavefront. Incident wavefront, reflected wavefront. So angle of reflection. Okay. Sorry. Reflected. Okay. So therefore, this is also 90 here. This is also 90 here. Is it clear? So again we can write V1 to and all. So BC, I'll write here A, B, C, A, B and C. So then what happens here? Mn is a mirror. Okay. So what will happen here? BC is equal to B tau, and AE is equal to BC is equal to again B tau. Okay. So both are equal because they're traveling in the same media, right?
Yeah.
They're reflecting back in the same media. So that is the reason they are exactly equal. That's it. That is about the reflection of the wave. We'll discuss prism thing, prism lens. One is prism lens, one is mirror. Three things we'll discuss now.
So that's E.
No, it's AC, right?
AC and DC. AE is equal to this.
E will be the 90-degree there, right?
What is the level? A, B, and then this is E. This one. Now we'll go to the three different diagrams. So this was also asked in one of the board exam to complete the wavefronts. Okay. Now clear this one.
Yeah.
Start. Now, one more here example. Suppose this is a prism, and this is the wavefront. He speaks that this is the wavefront. Draw the refracted wavefront. Complete the diagram and draw the refracted wavefront. Yes, what?
So
He said this is a
will be
wavefront.
perpendicular.
This is a wavefront, not the ray.
Yeah.
Students in their way.
that's the wavefront.
That's
So
the
then
wavefront.
you
The
take
ray
a
will go
perpendicular.
perpendicular to the wavefront.
Yeah.
Then they will refract.
It will be refract.
and then when they meet at the same
Means
point,
by the time it was here, it is still in there.
yeah,
Yeah.
Yeah.
So by the time, what will happen? It bends. Yeah, because
okay,
it
yeah,
bends.
it bends.
Okay, it bends like this. It is here now. Okay, but it is this much only. I will take care. Now, what will happen now?
Another way to go.
Now, by the time here, it is here. Okay, it come. Now, it is here, this is here. Okay, this came out, travels faster, still it is in the air. Okay,
Oh.
then what happens? Finish.
Then it's from the console.
Retracted that part. Understood now? This is how it travels. Now, for the lens, again, this is the wavefront. So, these are the rays. 3 rays I have taken. So, what will happen? This goes straight. So, here, inside, what will happen here? It is, the wavefront is outward, no? See? What happens? It converges to the focal point, right? So, this is the wavefront, right? See, it converges to the point. It is converging to the point. Wavefront is like this, right? So, the wavefront is like this. Understood now?
Oh, okay.
So, it is coming to the
So it
point.
comes towards that point.
So, better to
Then
complete
it will be-
complete the
yeah.
picture of the ray optics, then you will be able to draw the wave optics. Now, convex lens, concave lens. Now, the wavefront is like this. Means what? Rays are coming like this. So, after reflection, they converge to a point. Draw the wavefront. Line perpendicular to the rays. So, it will be like this. Okay, these are the wavefronts. Here. So, like that, they can ask you something to complete the diagram. People think what? I will tell you how they drew in exam. 9 is they draw. Yeah, they do that. And for this, they draw like this. For this, they draw like this. You know, these are all the mistakes what they do in the exam. So that is why I'm draw the ray diagram first. Then draw a line perpendicular to the ray. Automatically, you can draw the. Understood now? So we have taken one lens, one prism, and one mirror.
Yeah.
They can also go with the convex mirror and concave lens also.
Ah.
That to take it as a
So for concave mirror, it's the reflected wavefront. For the concave mirror.
left hand.
Yeah.
Yeah. Okay, so we'll stop the class here for today. Tomorrow we'll continue. Okay. Okay, John. We'll see tomorrow. Tomorrow, same 10 time. 10. If any changes there, I will update on WhatsApp.